High above us, in the vast expanse of the night sky, a breathtaking spectacle unfolds. Shimmering curtains of light dance across the horizon, painting the darkness with vibrant hues of green, blue, and red. This is the Aurora Borealis, more commonly known as the Northern Lights, a celestial ballet that has captivated humankind for millennia. Imagine standing beneath this celestial canvas, a silent symphony of light playing out above you. The air crackles with anticipation, a sense of wonder washing over you as the sky erupts in a breathtaking display of color and movement. The Aurora Borealis is a testament to the raw power and beauty of the natural world, a phenomenon that bridges the gap between our planet and the cosmos. The allure of the Aurora Borealis is undeniable, drawing travelers and skygazers alike to the far reaches of the globe. Its ethereal beauty has captivated artists, poets, and storytellers for centuries, inspiring countless works of art, literature, and music. Indigenous cultures of the Arctic have long held deep reverence for the aurora, weaving its presence into their myths, legends, and spiritual beliefs. To witness the Aurora Borealis firsthand is to experience a profound connection with the cosmos, a humbling reminder of our place in the vast universe. The sight of the aurora dancing across the sky evokes a sense of wonder and awe, a feeling that transcends language and culture. It is a reminder that magic exists in the world, hidden in plain sight, waiting to be discovered. Our journey begins at the heart of our solar system with the star that makes life on Earth possible, the Sun. This giant ball of plasma, a swirling mass of superheated hydrogen and helium, is a raging inferno of nuclear fusion. Deep within its core, under unimaginable pressure and heat, hydrogen atoms are constantly fusing together to form helium, releasing an astonishing amount of energy in the process. This energy, radiating outward from the Sun's core, is what bathes our planet in light and warmth, making life as we know it possible. But the Sun's influence extends far beyond the visible light that reaches our eyes. It is also the source of a constant stream of charged particles known as the solar wind that flows outward in all directions, permeating the solar system. Imagine the Sun as a giant cosmic heart, beating out a rhythm of energy that travels across vast distances, influencing everything in its path. The solar wind, this constant stream of charged particles emanating from the Sun, is not a gentle breeze. It is a powerful force, traveling at speeds that can reach millions of kilometers per hour. Composed primarily of electrons and protons, along with trace amounts of heavier ions, the solar wind carries with it the Sun's magnetic field, extending its influence far beyond the star's visible surface. Imagine the solar wind as the Sun's breath, a continuous exhalation that carries its energy and magnetic influence throughout the solar system. As the solar wind approaches Earth, it encounters our planet's magnetic field. This invisible shield, generated deep within Earth's core, deflects the Sun's charged particles. It is strongest at the poles, where magnetic field lines converge, allowing some particles to penetrate. Through these polar gateways, the Aurora Borealis begins its celestial dance. When charged particles collide with Earth's atmosphere, a spectacular transformation occurs. The energy released creates the shimmering curtains of the Aurora Borealis. The Sun, like a celestial conductor, sets the tempo for the aurora's performance. Its activity, characterized by the ebb and flow of sunspots, solar flares, and coronal mass ejections, follows a roughly 11-year cycle. This cycle, known as the solar cycle, dictates the intensity of the solar wind and consequently the frequency and brilliance of the Aurora Borealis. During periods of high solar activity, known as solar maximums, the Sun is a whirlwind of energy, unleashing frequent and powerful eruptions that send surges of charged particles hurtling towards Earth. These periods of heightened solar activity result in more frequent and intense auroral displays, painting the night sky with vibrant hues of green, blue, and red. Imagine the aurora during solar maximums as a grand waltz, a flurry of color and movement as the charged particles dance across the celestial stage. As the solar wind, a relentless stream of charged particles, hurtles towards Earth, it encounters an invisible force field, a protective bubble that shields our planet. This shield, generated deep within Earth's molten core, is its magnetic field. Imagine Earth as a giant magnet, its magnetic field lines creating a protective cocoon. This field is dynamic, constantly interacting with the solar wind. The magnetosphere acts as Earth's first line of defense, deflecting harmful radiation. The Earth's magnetic field, while invisible to the naked eye, is a powerful force, a testament to the planet's dynamic and ever-changing nature. It is generated deep within Earth's core, where the constant churning of molten iron creates electric currents that, in turn, generate a magnetic field that extends far out into space. Imagine the Earth's core as a giant dynamo, constantly generating the magnetic field that protects us from the ravages of space. This magnetic field, however, is not static. It is constantly in flux, influenced by both internal and external forces. The strength and orientation of the magnetic field vary over time, and it has even flipped polarity multiple times throughout Earth's history, with the magnetic north and south poles swapping places. These magnetic field reversals, while rare, are a reminder that our planet is a dynamic and ever-evolving system. The Earth's magnetic field lines converging at the poles act as cosmic highways guiding charged particles from the solar wind down into our atmosphere. These charged particles, primarily electrons and protons, follow the magnetic field lines like beads, sliding down a wire, spiraling down towards the polar regions. Imagine these charged particles as celestial surfers, riding the waves of the Earth's magnetic field lines towards the poles. As these charged particles funnel down towards the poles, they collide with the atoms and molecules in Earth's upper atmosphere, transferring their energy and setting the stage for the celestial spectacle of the Aurora Borealis. These collisions occur at altitudes of roughly 100 to 300 kilometers above the Earth's surface, in a region of the atmosphere known as the thermosphere. Imagine the thermosphere as a giant canvas upon which the charged particles from the solar wind paint their ethereal masterpiece. The Earth's atmosphere, a delicate shroud of gases surrounding our planet, provides the canvas upon which the Aurora Borealis paints its mesmerizing display of light. The atmosphere is composed of different layers, each with its own unique characteristics and composition. The Aurora Borealis occurs in the thermosphere, a layer of the atmosphere that extends from about 80 kilometers to over 600 kilometers above Earth's surface. Imagine the thermosphere as a giant rarefied ocean of gases, where the aurora's ethereal dance of light takes place. The thermosphere is characterized by extremely low density and high temperatures, reaching up to thousands of degrees Celsius. However, due to the extremely low density of the gas molecules at these altitudes, the heat content of the thermosphere is very low, and it would not feel hot to a human observer. The composition of the thermosphere plays a crucial role in determining the colors of the aurora. We've journeyed from the sun's fiery heart, traced the solar wind's path, and followed the Earth's magnetic field lines to the very edge of space. Now, in the rarefied air of the thermosphere, the magic truly begins. Imagine a single spark, a tiny burst of energy released as a charged particle from the sun collides with an atom of oxygen or nitrogen in our atmosphere. This collision, a meeting of celestial and terrestrial forces, is the spark that ignites the aurora's ethereal glow. These collisions, happening countless times every second as the solar wind bombards our atmosphere, are not mere bumps in the cosmic night. They are transfers of energy, moments where the sun's power is imparted to the very air we breathe. The energy from these collisions excites the atoms, bumping their electrons to higher energy levels like tiny subatomic springs suddenly compressed. The Aurora Borealis is not a monochromatic display. It is a symphony of color, a vibrant tapestry woven from the interactions of charged particles and atmospheric gases. The precise colors that grace the night sky depend on several factors, including the type of gas involved in the collision, the altitude at which the collision occurs, and the amount of energy exchanged. Imagine the aurora as a painter's palette, with each color representing a different combination of atomic elements and energy levels. Green, the most common color observed in the aurora, is the signature hue of excited oxygen atoms at lower altitudes, around 100 kilometers above Earth's surface. It is a vibrant emerald green, like the glow of a firefly magnified 1,000,000 times over. Oxygen, the life-giving gas we breathe, is also a key player in the aurora's mesmerizing display of light. When a charged particle from the sun collides with an oxygen atom in the thermosphere, it can excite the atom, causing its electrons to jump to higher energy levels. As these excited electrons return to their normal state, they release the excess energy as light, and the color of that light depends on the specific transition that occurs. The most common color associated with oxygen in the aurora is green. This vibrant emerald green is produced when an excited oxygen atom returns to its ground state through a specific energy transition. This transition, known as the oxygen green line, releases light with a wavelength of 557.7 nanometers, which falls within the green portion of the visible spectrum. Section 4. Nitrogen's blue and purple dance. While oxygen may be the star of the aurora's green performance, nitrogen, another abundant gas in our atmosphere, adds its own unique flair to the celestial display. Excited nitrogen molecules can emit a range of colors, from deep blue to vibrant purple, depending on the specific type of collision and the amount of energy involved. Blue auroras are typically produced when high-energy electrons from the solar wind collide with nitrogen molecules at lower altitudes, around 100 kilometers. These collisions can excite nitrogen molecules to a higher energy state, and as they return to their normal state, they release blue light with a wavelength of around 427.8 nanometers. Section 1. Hunting for the Northern Lights. For centuries, the Aurora Borealis has captivated imaginations, drawing skygazers to the far reaches of the globe. Witnessing this celestial ballet firsthand is a profound connection with the cosmos. But where should one go to maximize their chances? The Aurora Borealis is most commonly observed in the high northern latitudes. Countries like Canada, Alaska, Iceland, Norway, Sweden, and Finland offer some of the best vantage points. Section 2. A Midnight Rendezvous. The Aurora Borealis, like a nocturnal spirit, is most often seen during the long, dark nights of winter. From late September to early April, when the nights are longest and the skies are darkest, the aurora puts on its most spectacular displays, illuminating the night with its ethereal glow. During these months, the Earth's tilt positions the polar regions at a more favorable angle to catch the solar wind, increasing the likelihood of auroral activity. Imagine the Earth tilting towards the sun like a flower turning its face towards the light, its polar regions bathed in the stream of charged particles that fuel the aurora's celestial dance. As darkness descends, anticipation builds. The Aurora Borealis is not confined to a single location. It dances across the sky within a ring-shaped region known as the auroral oval, which encircles the Earth's magnetic poles. This oval, invisible to the naked eye but detectable by satellites, expands and contracts in response to the solar wind, its size and shape constantly changing like a celestial hula hoop. During periods of calm solar activity, the auroral oval hugs the polar regions, its southern edge typically hovering around 60 degrees latitude. However, when the sun unleashes a powerful burst of energy, such as a solar flare or coronal mass ejection, the auroral oval can expand equatorward, bringing the aurora's ethereal glow to lower latitudes. While the Aurora Borealis may seem like a random and unpredictable phenomenon, scientists have made significant strides in understanding the factors that influence its appearance and intensity. By monitoring solar activity, tracking the solar wind, and analyzing data from satellites, scientists can now provide reasonably accurate forecasts of auroral activity, allowing sky gazers to plan their aurora hunting expeditions with greater confidence. The key to predicting the aurora lies in understanding the relationship between solar activity and the Earth's magnetic field. Solar flares, coronal mass ejections, and other solar events can release massive amounts of energy and charged particles into space, triggering geomagnetic storms that can enhance auroral displays. Websites and apps dedicated to aurora forecasting use data from space weather agencies like NOAA's Space Weather Prediction Center to provide real-time information on the likelihood of seeing the aurora in different locations. The Aurora Borealis, with its ethereal beauty and captivating dance of light, has captivated the imaginations of humankind for millennia. Long before we understood the science behind this celestial phenomenon, our ancestors looked to the skies and wove stories, myths, and legends to explain the shimmering curtains of color that danced across the night sky. These stories, passed down through generations, offer a glimpse into the rich tapestry of human imagination and our enduring fascination with the cosmos. Imagine a group of nomadic hunters huddled around a crackling fire, their faces illuminated by the flickering flames and the ethereal glow of the Aurora Borealis overhead. The air is alive with a sense of wonder and mystery as the elders share ancient tales of celestial spirits, otherworldly beings, and the origins of the universe. Across cultures and continents, the Aurora Borealis has inspired a rich tapestry of myths and legends, each reflecting the unique beliefs and perspectives of the people who told them. In many indigenous cultures of the Arctic, the aurora was seen as a manifestation of the spirit world, a bridge between the earthly realm and the celestial realm. The Inuit people of Greenland, for example, believed that the aurora was caused by spirits playing a game of celestial football with a walrus skull. The dancing lights, they believed, were the spirits running across the sky, their laughter echoing in the rustling of the wind. Imagine the aurora as a celestial game, played out on a field of stars, the spirits' joyous cries carried on the night wind. Beyond the realm of mythology, the Aurora Borealis has also left its mark on folklore and superstition. In medieval Europe, the aurora was often seen as a harbinger of doom, a sign of impending war, famine, or pestilence. The sudden appearance of the aurora, with its blood-red hues, must have struck fear into the hearts of those who witnessed it, a reminder of the power and unpredictability of the natural world. Imagine a medieval village plunged into darkness, the only light coming from the flickering flames of candles and hearths. Suddenly, the sky erupts in a crimson glow, casting an eerie light over the terrified faces of the villagers. Is it a sign from God, a warning of impending doom, or simply a trick of the light? Today, thanks to the advances of science, we have a much deeper understanding of the Aurora Borealis. We know that it is not caused by spirits, gods, or magical foxes, but rather by the interaction of charged particles from the sun with the Earth's magnetic field. This understanding, however, has not diminished the awe and wonder that the aurora inspires. If anything, knowing the science behind the Aurora Borealis only enhances its beauty and mystery. It is a testament to the interconnectedness of the universe, a reminder that we are part of something far grander than ourselves. The same forces that create the aurora also power the stars, shape galaxies, and drive the evolution of the cosmos. The Aurora Borealis, a celestial ballet of light and color, stands as a testament to the awe-inspiring beauty of our universe. We've journeyed from the sun's fiery heart, traced the path of the solar wind, and witnessed the Earth's magnetic field deflecting these particles, painting the night sky with ethereal hues of green, red, blue, and purple. The Aurora Borealis is a symphony of the cosmos, a harmonious interplay of energy, matter, and magnetism. The Aurora Borealis, with its ethereal beauty and captivating dance of light, serves as a powerful reminder that there is still so much about our universe that we don't know. It's a call to embrace curiosity, to never stop asking questions, and to never lose our sense of wonder. As we explore the cosmos, sending probes to distant planets, peering deeper into the universe with powerful telescopes, and unraveling the mysteries of the subatomic world, we are reminded of the interconnectedness of all things. The same forces that create the Aurora Borealis shape galaxies and ignite stars. The Aurora Borealis is a gift, a reminder of the beauty and wonder in our universe. Thank you for joining us on this journey.